I'm gonna start with telematics, which is using technology to track cars and track drivers, and we are basically a solution that helps building better drivers. I started doing it in Belgium a couple of years ago. In December we moved to Poland, and we will be doing our project from Poland, because, as I said, it's a very interesting market. Myself, I've been studying mathematics and economics, doing quite a lot of projects in statistics. I wouldn't call myself a data scientist. I'm more traditional, old-fashioned statistician, but I work with people who know how to deal with big data and deep learning things. I'm also an actuary, so I've been working quite a lot for insurance companies, dealing with insurance projects, insurtech projects, and also transportation. The projects, I also wanted to talk about our journey, what we're doing, and how we are implementing, how we are using data, what kind of problems we have when we're dealing with data. And our project is a solution for fleets and car insurance companies to build effective loyalty programs for drivers. We are smartphone as a service solution, so basically we don't use any black boxes. We gather all the data from smartphones. So we use sensors of the smartphone to understand how people drive, taking into account how they drive, where they drive, when they drive, looking at their fuel efficiency when they are driving, and helping them to improve their driving behavior. So basically taking information from a smartphone, we create a comprehensive customer or driver profile, taking into account driving, demographic information, behavioral information, and building basically segments. As much information you can get about a driver as possible, such that it can be used by a fleet company, by insurance company, by roadside assistance company, and we implement our solution with rather bigger companies as a white label solution. Apart from analytics, there is a whole gamification aspects and feedback aspects. So we have a personalized feedback. There are challenges, rewards, campaigns, community aspects, so all information you can think of when you talk about gamification. Personalized feedback is very important. It's about your scores. And we look at how you are driving, so basically your speed profile, driving dynamics, where you are distracted during a drive, and we try to personalize information, give you information how to become a better driver and in different contexts. Also recently getting some social ratings, so basically comparing you to your group of people, your let's say social zone, people that might be important for you or drive the same environment. I don't know, the best driver, you're a driver in the suburbs of Paris, and then we compare you to the same group, or you're a Volkswagen driver, and then we can compare you as with other Volkswagen drivers. So as I said, we try to make it fun, because we know that just a pure analytical solution is not appealing to people. It doesn't reflect what people want, because some people want to be just better drivers. They want to compete with other people. Other people want to be rewarded for driving better. So there is also a reward platform with virtual rewards and actual rewards, I don't know, Amazon vouchers. And it's a personalized communication. So we basically segment, classify drivers according to who they are, and we try to address the right messages to the right people using the segmentations we have. So, aggressive driver and highway driver that drove today, and more than 10% of his time he was driving more than 120 kilometers per hour would receive a special notification how he's doing, or how many minutes that person saved by driving too fast There are countless possibilities here. There are also personalized sensitivity zones, so we do some prevention programs with schools, with police. Recently we have a program with schools in Belgium where we check, we help parents drive more safe in the school zone. So basically whenever a person accesses the school zone, we notify that and we give information to the driver. Okay, watch out, there might be some kids ahead, so better drive safer. You can use it in traffic jumps zones, or if you have a fleet solution when you are entering a fuel efficiency risky zone, then we inform the driver that you should take care of it. Is there any data science questions? There's a lot of say problems when you deal only with smartphone, because if you have something in a car like a black box, it's easy, it's there in one place, you know what you're getting out of it, and you can analyze it. When you have a smartphone, it's a lot of shit coming out of it. So you have to make sure that your smartphone as a sensor solution is robust. So I will try to talk over it about predicting user behavior and risk exposure using the sensor data, and touching upon marketing, because you could use this data to improving the marketing efforts you have in the company. One of the segments we're working with is a traditional insurance. Probably most of you have a car and car insurance. The traditional insurance is using static demographic data like age, vehicle information, your claims history, and so on. But it's changing. There are solutions, there are interesting services like Root Insurance, Metromile in the US that starts using behavioral data, so it's called usage-based insurance, that is using dynamic context data. So that's what we are providing to insurance companies. How you drive, where you drive, when you drive. Traditional models that are being used is generalized linear models or generalized additive models, which are very nice. Some companies use neural networks, support vector machines, but I've been working with those models, and they are not, it's very difficult to interpret those models. It's more like a black box, so actuaries and insurance companies prefer to use those interpretable models like GLMs or JAMs, if I can talk something about data science here. But what are the challenges? So we use smartphones only. I think the biggest is the data acquisition quality. First, especially on Android, you have 20,000 types of devices currently on the market. Most are working well, but it's always an issue. Myself, I have Xiaomi, which has a terrible OS in terms of sensor handling. So it's very difficult to get all the sensors in the right way, clean data that you can work and analyze. What we tackle also for more than a year is difficulty to acquire user data, because Apple and iOS are trying to make to support data privacy, which is good. Also optimize battery, which means that a lot of background services are being killed. So you need to find a ways that it works all the time, so that you have a 100% robust data, because those services are being killed. So you need to find some tricks, and also we work on Android and iOS, so we have to make sure that our algorithms are consistent across both platforms. I said battery optimization. It's GPS data is big. We take this GPS data every 6 seconds, but if you talk about sensors, it's every couple of milliseconds. So you need to find a balance between battery optimization and the amount of data you can do. So some of the algorithms you need to run on the smartphone. So you're not going to run deep learning on a smartphone. You need to have some simple classifiers or filters running there. So you always need to find a way to get the data analyze it partially on the smartphone and partially on your backend. Scalability, it's also, we had those problems, especially in the morning and in the evening when people go to work and they come back from work, then everyone is driving. So basically you need to make sure that all the trucks are being, it's so boring that it's closed. And of course, scalability and data labeling, if you want supervised learning. In some projects it's really nice. In the car it's a mess because you need to make sure that you label your data the right way, whether it's a passenger ride or it's a driver, what conditions you are driving in, so you make sure you have the right data for your algorithms. This is really time consuming, and you cannot do it a lot. And you cannot use Turks, you cannot ask people in India and in China. It has to be, you normally start with your own team, and then you have some beta testers and so on, but it's I think it's the biggest problem. So smartphone as a sensor, probably the easiest for us would be to use a black box. Because as I said, it's mounted in a car. We know where it is. We know what it gets, but it costs. So companies cannot afford getting smartphones. In most of the business cases, you cannot have a 100 to 200 euro black box mounted in the car because business case doesn't close. So we chose a smartphone which has a nice 3 accelerometers for other axes. There is a gyroscope. Magnetometer, and by doing a sensor fusion you can get the right data out of it. We started in the first place using the APIs from Google and Apple, which is nice because there is the newest Google Transition API gives you helps you identify what a user is doing with a phone. Either you're walking, cycling, you're driving, you're in public transport, or you're texting, for instance. It gives you a probability how you're doing. It's nice for activity recognition, but if you want to know more about what you're doing in a car, it's not enough, because we want to know who is a driver, whether it was a drive in your car or you were driving with a crazy Uber driver and your score is going down. So we need to recognize whether you were in a train or in a bus, what your braking profile or acceleration profile. So there are a lot of situations that the standard APIs don't handle. So we need to do some their own basically algorithms. And there are, of course, issues that I already mentioned: data size, a variety of devices, also phone handles, because some are magnetic, so they are interfere with sensors. So you need to take all of this. It's all fun if you're an engineer and data scientist. I'm more on the business side, so this is a hassle. So I'm always having the troubles because my developers always say, yeah, it doesn't work in this situation. And 50% of the time it will be working, 50 not, and then you have to explain it to your customers why it doesn't work. So this is not an easy situation. So as I said, some of the work we are doing on the smartphone side. Using some filters. There's also some fun at work because we're doing real crashes with cars. So this is, for instance, a G-force from a car crash that we did. So we crashed a car with a motorcycle. It's 48 kilometers per hour. So you see some bumps. You can really see that there were let's say high forces, and you need to identify those. This is a phone drop from 1.6. It is also can be high, but you have to distinguish between those two situations. And there's also momentary jitter, false positives, especially on the cheap Chinese phones. It's terrible. So some don't have all the sensors. You need to be sure that the data coming out of it it's robust, or you basically inform the user that on his or her phone the solution won't work. This is also a tricky part, how to inform a user that its phone is shitty. And it's not your fault. It's not your fault. It's not working, but it's I don't know, Xiaomi or Huawei, because it's cheap, but it's not good quality. Another challenge we're doing is the activity recognition of multimodality. So we want to move from cars into multimodal approach, so offering services to companies that want to offer solutions not only for cars, but public transport, bikes, and so on. So we need to recognize what you're doing with your phone, whether you're walking, cycling, on a train, on the bus. And you can do it with sensors, but we also add some spatial information and real-time. So I don't know, when we analyze a train trip or a trip, we check, we use OpenStreetMap, so we check whether there are any train tracks, bus stops, and so on. We take into account the speed the person is moving, the average speed profile, and so on. So you can always find ways to use third-party data, get your algorithms better. Important information I've already said. It's who is driving, whether it's a passenger or you're a car driver. So this is using, of course, sensors, but that's something we're working on. We don't have it yet, but basically it's creating a driver profile based on different trips and on the sensor information we have. And having a new trip, we can identify how this matches your driver profile. We probably need to use deep learning, so conventional neural networks. We probably know how to do that. It's not easy, but yeah, there's constant improvement into that. And of course, manual labeling is tedious and expensive task. We need to do. That's why also deep learning. We think we have a lot of data that is not labeled, but we think using our data, which it's a couple of millions of kilometers, we can put it in deep learning and in neural networks, and it will help us overcome this. But I don't have all answers to this problem yet. As for marketing, that's something also new, because currently we have a couple of projects across Europe, and companies are asking us, okay, we have drivers, but we want new drivers into our platform. So why not combine our information about the users with Facebook and Google, and try to? So we are also discussing with companies how to generate ads that generate best results for a given group, and when to shut off or turn off the ads at the moment, because we spend, I don't know, €20 on Facebook. What is the moment to shut it off? How to optimize your marketing budget? So these are very interesting questions. Again, this is on my wish list still, but I know that companies are looking into that, and you can combine the AI machine learning into that as well. And also advertising direct audience. Facebook gives you a lot of opportunities. It's very expensive to get to the right people, but combining it with the data that we have about customers and drivers, I'm pretty sure we can get it better. So these are my future plans. Something we're gonna do this year. So improving our smartphone as a sensory technology, so activity recognition, getting into multimodality. We're very happy that we have a new president, Trzaskowski in Warsaw, because he's a technology fund. So we're discussing with Warsaw to start some interesting multimodality projects, basically moving people from cars to public transport to bikes, and doing some gamification around it. But we first need to improve our multimodality algorithm. passenger and driver detection I mentioned, and driving detection. And this is probably something missing. That's probably about event detection, driving event detection, making sure that we identify acceleration, braking, accident detection better. It's also we have certain algorithms for driver profiling and rating. We would like to improve them, so make them social. Use these social zones for every driver to identify, to help people drive better by bringing your social environment into the system. User support is probably a big thing that needs to be improved. I mean, you can automate a lot. There's a lot of Zendesks and this kind of solutions, but we have a lot of questions from drivers about their trips. So basically they said, hey, why do I have 5? I was driving very well. And it appeared that when you were leaving highway, for instance, the guy was driving 120 and it was already 50 kilos per hour speed limit. So it's a kind of manual work. You need to sometimes go to the Google Street View, analyze, get some data from Waze or from OpenStreetMap. So analyzing every trip is very, it's time consuming basically. So we would like to optimize it. Also gets, I don't think bots, it's a good idea for us for this, but yeah, certainly there's some machine learning that could be used. I mentioned marketing and third-party integration, so we want to get weather, traffic, and different modes of transport information about public transport into the system to improve our algorithms. As we're growing, we look for data science interns. So if anyone interested to work with a lot of data that we have, you're welcome. And I think that's it.